Okay, as I just said, today's lesson is going to be on ratios and proportions. In the previous class, I said again, the concept of it seemed to be really simple, and they're like, oh, this is easy, but I'm actually going to do it in a slightly harder way, like an algebraic way, because in the future, you will get examples where you can't just guess and figure it out. I'm going to show you a full mathematical proof of how to find values you normally didn't know. So people can't refute it, people can't argue, and you can also use that method for your future. So it might start easy, and you might be complaining like, why do I have to do it your way, Mr. Kim? It's so hard. See if you can walk me through it, or walk with me through it, okay? Here we go. Everyone have their sheet in front of them? Pencil? Working through? Come grab one. Here we go. When we describe proportions, in other words, a ratio or a comparison of two different numbers, we can typically write it in the form of x colon y, some number to some number. Like if you watch like Looney Tunes or any other kind of cartoons where people are making proportions. I remember when I was a kid, there was an episode where like it was Looney Tunes, like what is it, Bugs Bunny and stuff like that. There are two robbers and they just robbed the bank. There's a big robber and a tiny robber, and he's like, well, I have to eat twice as much as you do, so I deserve twice as much money. So he would like put 2 stacks of money in his bag and 1 stack of money in the other person's bag. And just, the other one's like, that's not fair. We work both just as hard. We should split it equal. And that was the premise of the episode, right? Essentially, that's what ratios are. It's proportion. We can write it in a lot of different ways. Let's say, for example, if I ate, let's say, 2 servings of food, but my older brother, let's say, ate 4 different servings of food, it's a 2-to-4 ratio. But you can also reduce that and say it's just 1-to-2. Why do we make it complicated? It's just 1-to-2. There's so many different ways we could write ratios. So we're going to explore that. If this is just simple and easy for you, bear with me. The first way we write ratios is what we would call part to part. In other words, how many of one versus how many of another. Different from example 2. So let's say, if I have 10 apples and 13 oranges, the ratio of apples to oranges, consider the colors. Apples to oranges are going to be 10, 13, right? The numbers and the wording have to be identical. In other words, English-wise, it has to be the word respectively. You remember reading that, right? No? The ages of Abe, Graham, and Lincoln were 5, 6, and 7 respectively. You get what I'm saying? You've probably heard that before. Anyways, it's really important to respect and recognize the order in which it's stated in English and then stated as a number. In the same way, you don't have to say it part to part. We can actually talk about a part to a whole. In this particular case, the whole would be the total. The part to total. So you can obviously see that the number of fruits that we have is 10 plus 13, it's 23. The ratio of apples to total is 10 to 23. So far, so good? Any questions so far? It's not supposed to be trick questions or anything. Any questions so far? Everyone's okay? Just nod your head. All right. Now here's a kicker. If we are able to write it from a part to a total, doesn't that seem familiar as us saying, let's say 10 pieces out of the 23 pieces? Remember when we were talking about pizza slices or whatever? It's basically a fraction. So ratios can be rewritten as a fraction. And if a part to a whole can be written as 10 to 23, well, a part to part can also be written as 10 to 13. It would simply be not to a whole, it would be 10 apples to 13 oranges. You can write ratios as fractions and vice versa. Any questions? No? Okay. Well, let's see some examples in action. Moving down, I'm going to start with B and then C. And then I'll go back to A. There's a reason for that. I have 8 red marbles, 11 blue, and 9 yellow marbles. In total, there are 8 plus 11 plus 9. There are 28 marbles in total. That's for future reference. The question says, please write a part to part. Yellow to blue. I have 9 yellow to 11 blue. Done. Simple. Simple. Blue to red. Blue to red. Done. Simple. Simple. Here's the next part. Red to yellow. I'm going to write it a little small. Red to yellow. Oh, sorry, I got mixed up. I could have done this left to right. The second question, I want to do B and C first. Sorry, red to yellow is 8 to 9. Part to part. I do not need to write 8 red, 9 yellow because the order is going to be respected. That's a given. So you don't have to reiterate that. It's a waste of your time. Let's move on to the next one, part to whole. And remember, we have 28 marbles total. Okay, here we go. Red marbles. Sorry, let's do blue. Blue marbles. Blue marbles means automatically it's blue marbles to the total. I don't have to specify it. That means I have 11 to 28. Or, of course, let's just get used to writing it in fractions, 11 to 28 this way. Yellow marbles, 9 to 28, or, of course, 9 over 28. The last one, we're going to start implementing some things we've learned in fractions. Take a look. Red marbles is 8 to 28, or I can rewrite that as 8 to 28. But if we write it as a fraction, it is absolutely preferred to write in lowest terms. Yeah, and so what do I divide both numbers by? What's a common multiple or common factor rather? Yep, sure. So 8 divided by 4 is a 2, 20 divided by 4 is a 7. So 8 to 28 is just as good as 2 to 7. They are both the same ratio, same proportion. That's the first portion that we're half done. Any questions? Because we'll see some more examples in action. Once, going twice. All right. And you're okay? Are you okay? Are you following along? I hope you are. Can you put that down? All right. As an example, Shazara is having a family picnic with their cousins. 6 cousins are drinking Coke, 8 cousins are drinking Sprite. Write a part-to-part ratio. So remember, As a reminder, that's 6 and that's 8. A part-to-part ratio for Coke and Sprite. Remember, the order is respected. It's 6 to 8. And then it says rewrite this ratio in lowest terms. You know that 6 to 8 can be simply rewritten as 6 over 8. And you can reduce that fraction. It's 3 to 4. Essentially, 6 over 8 is the same as 3 to 4. Part to whole for Sprite. Sprite is 8. The total is 14. And then part D, it says to write in lowest term. So again, 8 by 14 is the same as divide by 2 on both sides, 4 over 7. The ratio of Sprite to the whole is the same as 4 to 7. Yes. Yes. Everyone, this part is simple. So now we're going to get to a weird portion. And we're going to start easy, but I'm going to change the game and force you to use algebra because it is the more foolproof way. Take a look at letter E. And please remember these numbers. The numbers that we just calculated. Imagine there were 21 cousins at a picnic. The ratios remain the same. So what's the ratios? Coke to total, it was 3 to 7. Yep. Huh? Oh, sorry, what was that? The Coke to total. So it was 6 over 21. No, it was 6 over 14, sorry, which is 3 over 7. Good. And for Sprite to total, it was 4 over 7. Okay. How many cousins would be drinking Coke and how many would be drinking Sprite if I had 21 cousins? Here it is. Ready? The ratio is Coke to total. Coke to total is 3 to 7. What if the total wasn't 7, but it was 21? How do I go from 7 to 21? I'm going to write it like this. So this is my mystery X. I'm starting to introduce algebra now. It's my mystery and we're going to call it X. If I went from 7 to 21, I must have multiplied the denominator by a 3. But of course, I can't just do that randomly. I'm only allowed to multiply by 1 so that I don't change the value. And so 7 times 3 is 21. That means X must be 3 times 3. It must be 9. That's one way to do proportional reasoning. Does that make sense? Ask away, please. By all means, stop me. And of course, if you did it once, you can do it again with 4 over 7. That's all right. Okay. Times something equals, I'm going to call it y over 21. And again, you're multiplying 3 over 3. Okay. Therefore, y is equal to 4 times 3, which is 12. Now, you didn't have to do it this way. You can also use some logic. 9 people were drinking Coke. Use some logic. Go use math, use logic. How do you get to this? 9 people are drinking Coke. What?
21 minus 9.
Yeah. There's 21 in total. So out of the 21, 9 is gone. So the remaining people must be drinking Sprite, right? So you can use logical reasoning as well.
Why wouldn't you just do that?
I just wanted to demonstrate so that you see what I'm doing every single time. That's all. Why are we getting to this point? Why am I introducing an x? And this is where logical reasoning, equivalent ratios, and proportion, this is where it all starts. I am going to show you what particular thing we might be looking at more often, and then turn it into an unknown x. Okay, here we go. Equivalent ratios. So you know, for example, that two ratios, if they are identical, they can be, well, equivalent ratios are when two ratios can be all written in those terms and they end up being the same. Right? So if you have 5 or 25, if I were to reduce these, in other words, divide top and bottom by 5, you get 1/5. And so 5/25 and 1/5, they are going to be the same. 5 to 25, 1 to 5, they are going to be the same. So let's figure it out. Take a look at the first example on the bottom. 12 to 8, 3 to 2. Are they equal? Or are they equivalent ratios? What do you think? How would I get 8 to become 2? Or how do I get 2 to become 8? We can go either direction. 7? Not by 3, but yeah. So if I divide both sides by 4, top and bottom rather, 8 divided by 4 is 2. 12 divided by 4 is 3. Yay. So this ratio, so therefore 12 to 8 and 3 to 2 are equivalent ratios. Here's a harder one. 3 to 5. Is it equal to 50 to 70? Oh, sorry, 50 to 75? How do you know? Well, let's start. Well, 50 isn't divisible by 3. Well, again, we need to show some proof. What can I multiply to change 5 as a denominator to 75? You do outside. 5 times 15, right? So let's try it to the top as well. 5 times 15 is 75, but 3 times 15 is 45, not 50. So in other words, they are not equal. So you simply, just from this, just from multiplying with a fraction of 1, we have proven that it doesn't. So up until now, I have given you numbers that sort of work. The very last part of today's lesson, this is the last bit. We're already at the end. The rest of the page is just homework. The last 3 examples, I am going to try to solve using algebra, because I believe instead of just looking at this lightly and be like, oh, I could guess the number and get it, I would like you to develop the ability to solve this with no questions. So follow through with me. I hope that you will entertain these thoughts. Let's do this. Every time you have a question with an X, in other words, you're trying to get through algebra, I would like you to mentally set your goal to get X all alone. That's some background. How many people here have heard the term cross multiply? 1, 2, 3. Is that it? Yeah. No, seriously, I need to know. Cross multiply. I don't need you to know how to do it. I need to know if you've heard of it. Cross multiply. Whoa, okay. All right. And I'm not even going to go in that direction. Let's pretend you don't know it. Which, you know what, it's not bad because I don't have to necessarily unteach you that. When, let's start with this. Let's pretend this is the first time you've seen anything like this. I'm going to ask you some questions and then get you to follow through. Let's say you don't like fractions. Well, let's get rid of the fractions. Right now, the 9 is being divided by a 12. How do you get rid of a division of 12? What's the opposite of a division of 12? John? Why not? Right? I am going to multiply both sides by a 12. Now bear with me, okay? Notice how I'm doing it on both sides because there's an equal sign. Mike, hang in there. Hang in there. Okay, hang in there. Let's multiply. Division of 12 and a multiplication of 12 are going to reduce into 1. Leaving you 9 on the right side, and this becomes 300. 324. I'll stop right there, soak it in. Any questions?
Why did the 12 cross out?
Good question. Division of 12, multiplication of 12, they will reduce and become 1.
What do you mean by division of 12?
Well, 9 divided by 12. So 9 right now is being divided by 12. We know that's what a fraction means. How do you do the opposite of a division of 12 to essentially reduce it to 1? We multiply. That's where it came from. So anytime you want to get rid of a fraction, so the denominator, multiply by that number, right? Yes. Yes. Multiply the denominator, so multiply this fraction with that number. And that will reduce into 1. It'll quote unquote divide out, it will quote unquote cancel out. This becomes 1 and that becomes 1. Let's do it again. Let's say you don't like fractions, and I know most of you don't. How do I get rid of a division of x? And it's the same thing. Division of x. What's the opposite of division of x? Same thing. What's the opposite of division of x? Marshall? Multiply. We're going to multiply both sides by x. Hang in there, everyone. I'm almost done. So division of x, multiplication of x, they will reduce to 1, leaving you with 324 equals 9x. Yes. You're right. Why not just do it with proportional reasoning? But what if I give you something like this, where you can't? That's the problem. I know all of you can use 1, 2, 3, 4, 5. I know all of you can actually use 1.5, 2.5, 3.52. Some of you might be able to multiply by 1.25, 2.25, 3.25. But once you started multiplying by 1.27136 or whatever weird, obscure number that you have, you still need to be able to solve it. And this is why I'm showing you how to break it apart piece by piece. Let's get rid of all the fractions to make sure we don't make any mistakes. And now that we're here, let's get x all alone. Right now, x is being multiplied by a 9. How do I get rid of a multiplication of a 9? Divide both sides by the 9. So when you do that, 9 divided by 9 is a 1. 324 divided by 9, throw into your calculator, you will get 36. Now I know 9 times 3 is 27 and 12 times 3 is 36. I know, but again, I'm forcing you to do it this way because you might get hard numbers in the future, right? Two more examples. Yes. Okay. We'll do an example again. Here we go. 14 over 12. Let's do it. Come on. I don't want the fractions there. Let's start with this side. I don't want the fractions there. What do? Okay, Ellie? That's what right now is division of 2 already. So the opposite is? Yeah. Okay, so we're going to multiply both sides by 2. I need some more space, don't we? Okay. I'm going to multiply by 2, multiply by 2. This side, is going to be simplified out, leaving me with 14 equals 42 over x. We'll do it again. I don't like the fractions. Let's get rid of a fraction. We're going to multiply both sides by. Oh, yeah. Thank you for whoever said that. Times x times x. We have 14x equals, and you know that this is going to be reduced into 1. It's just 42. And lastly, x is not all alone. Right now, x is being multiplied by a 14. How do I get, what's the opposite of multiplication of 14? Division of 14. So we're going to divide both sides, because you have to keep it equal. And when you do 42 divided by 14, you will get 3. And I know you might say, hey, Mr. Kim, you can go from 14 to 21 by multiplying by a 1.5. So if I multiply 2 with 1.5, I get a 3. I know. But again, what if the number was 1.5? What if it was like pi or something? Right? Some weird number that you can't wrap around your head that easily. This method is going to be foolproof, even if it's long. And all you have to remember is do the opposite of whatever you see. If it's a multiplication, divide it. If it's a division, multiply it. You're just trying to get rid of things and make it less complicated. Any questions? Because I have one more for you, and then you probably have like a good 25 minutes, just like melt your brain, okay? And just relax. Here we go. Last one for today, okay? Hang in there. Everyone, this one might seem a little bit more difficult, but I want to bring your attention to a ratio with 3. This ratio you might use in chemistry once you get to grade 11. But you need to know your math anyways, and might as well just do it now to get you to think. I am not going to write a fraction as 4 over x over 15 is equal to y over 9 over 30. That's just ridiculous. Instead, I'm going to focus on 2 numbers at a time. I am intentionally going to focus on the numbers that we can't solve yet. Take a look at red to green. 4 over x equals y over 9. Can you solve that? No. So I'm going to put a stop to it. And let's come back. Instead, green to blue, green to blue. X to 15 is equal to 9 to 30. Can you solve this? The answer is yes. So let's do it. Luckily, this time the x is not on the denominator. Yay. Let's get rid of the fractions. So you're looking at me so confused. Ask a question.
I don't understand the fully that all three wants to be.
Okay. Again, let me know. Yes, Ron? Oh, okay. It was let's move to the next one. Marshall, are you keeping up? What's happening here? What should I do to get x all alone? Take a look. I want this all alone because that's the x, right? You're trying to figure out the unknown. How do I get rid of this part? Maya? Correct. It's a division. So do the opposite. We're going to multiply both sides by 15. And I have, again, let me cross out. That becomes 1 and 1. X equals, 945, 135 over 30.
Wait, but why are you using 930? Why?
Pardon?
What happened to the y?
I'm not doing y yet, right? I'm just doing this part right here. I'm not doing the red color. Oh, look, X is already all alone. Look at that. I actually don't have to go any further. X is all alone. I solved it. And if you put this in the calculator, I think it actually comes out to a 9 over 2. Or it comes out to 4.5. If I reduce it, it becomes 9 over 2 or 4.5. Yay. Why am I yaying about this? Because I could bring it back in. Sorry, Ron. Right? If I bring it back in, because I have my X now, look, 4 over 4.5 is equal to y over 9. Oh, shoot. Sorry. Why did I do y over x? It's just 4 over y is equal to x over 9. So 4 over y is equal to 4.5 over 9. Right? Because I found my green x as 4.5, so I could plug it in right here. And again, you have to do the same thing. Let's multiply both sides by 9. Let's multiply both sides by y. You do a whole bunch of calculations and your final answer should be, let's see, 8. I wonder if you can figure out what all the steps are in between by doing what we've practiced until now. Now, again, I've sort of semi-vomited a lot of information at you, getting you to do a bunch of algebra in the midst of ratios and proportions. But I think instead of teaching you in a simplistic way and getting you to be like, oh, I know this, I could do whatever number, and then suddenly hitting a wall and be like, I can't do math. No, that's not true. There is a way to do all of these things. I hope that you'll walk through with me and try practicing this algebra method, because it's going to go with you a long way if you're able to master this. Okay. Now, you do have 25 minutes with me, but I know you people are tired. Maybe in class, you can try like number 135 instead of all of them. Just try 135 for homework. You can save the other ones for maybe a test study or whatnot. Try 135 for homework and we'll see how far we come tomorrow. Okay, any questions? Okay, let's get to work.